Hello Professor, in this video I would like to build a decision tree model using SAS Enterprise Miner for the liver disease dataset. For that I'm using the file import node. I'm importing the file. Here we need to predict whether the patient is a liver disease patient or not. So my target variable is liver patient here. So I want to partition the data using the data partition node. I'm partitioning it in the ratio of 40 for training, 30% for validating, and 30% for testing. So I want to build two decision trees here, so therefore I want to use a control point here. So let's build the decision tree. Let us run this. Let us check results for this. Though the result window is showing different panes, let us concentrate on this decision tree. So from this decision tree, it can be inferred that the total bilirubin is the significant variable since this node is at the top of the tree, and to the branch right out to the total bilirubin, that is if the total bilirubin is greater than 1.65, we are expecting maximum proportion of ones. Those are the people with the liver disease. And or also we can observe that the SGPT, alphos, and A's are also the significant variables since they are present in this tree. The SGPT is the alanine aminotransferase, and the alphos is the alkaline phosphatase, and these are the significant variables. Since decision tree is very easy to interpret, if you have the values of these variables, there's a high probability for us to predict whether the patient is liver diseased or not. So let us go to the output tab here. So though there are several aspects, the one which is important to us is this confusion matrix. Using this confusion matrix, we can find the accuracies of the model that we have built. The important point I want to explore is the maximal tree that is being created on the training data by the algorithm. For that I want to build an interactive decision tree. So I'm building an interactive decision tree for this. So we can decide the top node by using the split node. The most important point to note here is the statistic, the log width. The log width decides which variable to be split. So the more the log width, that is the variable being selected as the node. So log width is the negative log of the p-value for this variable. Since the log value of this total bilirubin is more, this is being selected as the top node here. So we can split the node further interactively like this. So instead of doing that, we can directly train the node. This is the maximal tree that the algorithm, this is the complex model that algorithm can generate using just the trained data. I'm freezing this model. The frozen tree prevents the maximal tree properties from being changed. So I want to implement this model on the validation dataset as well. So I'm running this node. Let's see result of that. Let's see the tree. So this is the optimal tree that the algorithm has come up with on the validation dataset after pruning. So let us see the assessment plot for this. See, my area of interest is misclassification rate. See, if the number of leaves are increasing on the validation dataset, the misclassification rate on the validation dataset of the model is getting increased. So the algorithm come up with 6 as a number of leaves for this model, for which the misclassification rate is very low. Thanks for watching.